So hi, today we are going to look at a question on matrices, and the question reads: given that A is equals to 3, 2, negative 1, 4 and B is equals to 5, negative 1, 2, 0, and that A squared is equals to BC, find the matrix C. So in this particular question of matrices, the first thing we're going to do is to look for A squared. So to be able to get A squared, we are going to multiply A by itself. So we'll have 3, 2, negative 1, 4. This one we multiply by itself, which will be 3, 2, negative 1, 4. So in this particular case, 3 times 3 is 9. Then negative 1 times 2 is negative 2. 3 times negative 1 is negative 3. Negative 1 times 4 is negative 4. 2 times 3 is 6, plus 4 times 2 is 8. Then 2 times negative 1 is negative 2. Then 4 times 4 is 16. So this will be equal to 9 minus 2 is 7. Negative 3 minus 4 is negative 7. 6 plus 8 is 14. Then negative 2 plus 16 is also 14. So that will be the answer when you work out A squared. Then after that, we now come to working out the whole equation. We'll have 7, 14, negative 7, 14, that's the value for A squared, is equal to BC. The value of B is 5, negative 1, 2, 0. This one multiplied by C. So for this particular case, we need to get the inverse of this, because in matrices there is no division. So if you want to remove any matrix from one side so that you only remain with C, we need to get the inverse, which acts like the reciprocal of a given matrix. Then we multiply on both sides. So here it will be 1 over the determinant. The determinant is 5 times 0, which is 0, minus 2 times negative 1, which is negative 2, then into the main diagonal interchanges, it becomes 0, 5. The other diagonal changes the sign, we have negative 2, positive 1. So this will be equal to a half into 0, 1, negative 2, 5. Then this particular matrix we pre-multiply on both sides. So that means we'll have a half into 7, 14, negative 7, 14. Actually, it won't be that way. The inverse itself, which in this particular case it is 0, 1, negative 2, 5. We pre-multiply on this side, 7, 14, negative 7, 14 is equal to, we do the same on this side, pre-multiply. It has to come first because matrices is order specific. This multiplied by 5, negative 1, 2, 0, then multiplied by C. Now whenever you multiply a matrix by its inverse, the answer is always a unit matrix, 1, 0, 0, 1, which acts like 1. That's how we remove a matrix from one side to another. So the only thing now, if this is 1, it means this side will only remain with C, is equal to, we work out this other side. It will be a half into, this will be 0 plus, so 0 minus 28, then 0 minus 28, then 7 plus 70, and then negative 7 plus 70. So eventually the value of C eventually the value of C is going to be the same as a half into negative 28, and then also 0 minus 28 will be negative 28, and then 7 plus 70 is 77, and then negative 7 plus 70 is 63. This will be the value of C. We can leave it this way, or we can simplify further by multiplying everything here by a half. So that is going to be our answer. So in this particular case, when I'm solving this question, first of all I had to get A squared, and then to be able to make sure C remains itself by itself, I have to pre-multiply the inverse for this matrix I want to remove, so that it gives me a unit matrix. That's how C will remain alone, but we pre-multiplied on both sides so that you're able to get or balance the equation. And when you work out that part, you get this. When you simplify, you get that, and that will be the value of C. I hope that has been understood. Thank you, and see you tomorrow.